Okay, so welcome to kickoff webinar for the GPM-GLOBE Student Field Campaign. I'm going to tell you a little bit about the GPM satellite and a little bit about what you'll be involved in joining in this campaign today. So, and then we'll have some time for some questions afterwards. So first of all, when you think NASA, what do you think of? Maybe just type some comments in the chat window, or if you're in class, you can shout out. What does NASA make you think? Okay, so we've got rockets, space travel, physics. So what I get from students, yeah, we'll hear about astronauts or the space shuttle, stars and space, galaxies, planets, all those sorts of things. What people don't always realize is that NASA also studying Earth and spends a good bit of time studying Earth, and it's really important that we study planet Earth as well. And specifically what the mission that I work for and the data you're going to be collecting is related to precipitation. And I guess I actually failed to introduce myself. My name is Kristen Weaver. I'm an education specialist for the Global Precipitation Measurement Mission. And so when we're looking at water, it looks like on the Earth there, if we look at our picture of the Earth, it looks like there should be plenty of water all around. But it turns out that a lot of that water isn't really usable to us, that only about 1% of that water is usable by humans. And of that, a lot of it's underground, some of it's in lakes and rivers, but it really isn't as much as you would think. And if we look at this second graph, you can kind of see a breakdown of where all that water is. And so knowing that we have so little water on Earth, it's really important that we pay attention to what water is there and that we kind of track what water is there. So that's why we need to study the water cycle. And specifically for this mission and the observations that you'll be doing, we're studying precipitation. So the rain and snow. And, you know, the easiest way to measure rain is just to stick out a rain gauge, you know, a very simple cylinder outside. You see how much rain there is after a certain amount of time. But the problem is that they're not very evenly distributed around the Earth. And they aren't over oceans. All those little dots that you can see, those yellow dots on the left, are actually rain gauges, but you put them all together in one place and you only have about 2 basketball courts worth. So that's not really a lot of coverage. So what about radar, you might ask? You've probably seen that on the evening news, the radar coverage. Well, that also has some gaps, and you can see in the US there, even though it has good coverage, there are still some places that aren't as well covered, and it doesn't go very far out of the oceans. So that's really not quite enough either. So what we need are satellites, like the GPM Core Observatory that launched about a year ago in February 27th actually, so almost exactly a year ago. And it has 2 instruments on it. One of which is the microwave imager that you can see where that arrow is pointing. You're seeing those areas of red. That's showing heavy precipitation. And then it also has a very cool instrument that's a precipitation radar that actually can see that kind of 3-dimensional structure of clouds. So it allows us to see not just total precipitation in an area, but actually where in the cloud this precipitation is happening and whether there is the snow up in the top of the clouds and where the rain-snow line is, and all sorts of great information that we can see because of the precipitation radar. So we need those instruments. You can see this diagram shows some of the other parts of the satellite that you need to support the instruments. We've got the precipitation radars on the bottom. There's the GPM microwave imager. Of course, we need solar panels because we need electricity to power our instruments. We need the propulsion module and reaction wheels to adjust the satellite in its orbit, an antenna to send down our data. And then the avionics and star trackers, those kind of tell the satellite where it is in space and help the engineers who are maneuvering it know exactly how they need to adjust it. So how will you be involved as students? Well, satellites see precipitation a little bit differently than just putting out a rain gauge or even the ground-based radar I talked about before. So we have to compare the data from the ground to the satellite to be able to see that the algorithms, the computer programs we use to process the data are working. And we have to compare the data from the ground and from in space. So that's where all of you come in. When scientists go and do a ground validation campaign, they go and send out a bunch of rain gauges and put them all in one place, and then they measure precipitation, and they may have airplanes flying over, they have a satellite flying over. But what we're going to have you do is contribute to ground validation with the rain gauges set up at your school. So you'll send your data in through the GLOBE database, and then we'll have some scientists, I guess I have on the next slide. So you'll be collecting the data, sending it into GLOBE, and then we have some scientists working with GPM to look at it, compare it, analyze it, doing comparing it to other rain gauge data as well as to the satellite data. But of course, we don't want to let the scientists have all the fun. We want you guys to have some fun too. So you'll have opportunities to do your own analysis using data from schools around the world who are contributing data, as well as looking at things like changes in climate averages. And is this season a normal season in terms of rainfall, or is it drier or wetter than usual? So you will be, a GPM junior scientist using this data and doing your own analysis. So there's some examples of some of the data that you can get, some of the ways you can look at it and analyze it, and you and your teachers will have some opportunities for you to be able to help analyze this data and look at how to get some of this data. And then really the important thing is not just collecting the data, but also being able to use it for some purpose. So these are some examples of what we can use the precipitation data for. Flooding, landslides, looking at improving weather and climate models. Where do we have enough fresh water? Where do we not have enough fresh water? Hurricanes, where are they going to hit? How intense are they going to be? Extreme events like snowfall, and actually some interesting world health applications as well. So even though we're all over the world, everybody, and NASA, we think of looking at outside of Earth, but NASA is also studying Earth as well. And so part of you will be part of this, looking at Earth right now. And just a reminder, this is why it's important, because things happen to people, precipitation affects people, and it makes a difference for people in the world, and it can cause problems. It can be good and it can be bad, but we just need to know where the water is and what's happening to be able to prepare for both aspects. So if you want any more information about the TRIM and GPM missions, there are some websites you can look at and submit any questions you have. And please welcome to the GPM-GLOBE Student Field Campaign.